Okay, here is our review for the Chapter 10B test. A sample of 50 donors was chosen to take a survey asking for their blood type. The results are shown below. If a donor is chosen at random, what is the experimental probability that they responded with blood type AB? So we've got our AB column. We know there are 50 donors total. So 5 out of 50, which we can simplify to 1 out of 10. You could also put a decimal or a percent. Those are both fine. For the easy fractions like this, I will likely leave it a fraction. I just want to make a note about experimental probability, just because it's been a little while since we talked about that. Experimental probability is the probability that from an actual survey or experiment or poll that you conducted, something that actually happened out of a total of how many people responded or participated in whatever you were doing. Theoretical probability is the other kind, and that's what should happen. So, for example, when you flip a coin, you should get heads half the time. You should get tails half the time. But if you run an experiment, maybe you won't get it half and half. Maybe it'll be a little bit off and one will come out more. So experimental probability is what actually happens. Theoretical is what should happen. All right, next question. You roll a fair 12-sided die. What is the probability the roll will be an 8? So, assuming it's numbered 1 through 12, an 8 is only one of the sides. So, it is 1 out of 12. Odds makers in Las Vegas are saying the probability of the Timberwolves making the playoffs is 1 out of 50. They are saying the Wild have a probability of 4 out of 5 of making the playoffs. What is the probability that both the Timberwolves and the Wild make the playoffs? So this is an and problem, so we are going to multiply. 1 out of 50 times 4/5, and we should get 4 out of 250. I'm going to double check that bottom number here. Yep, 250. Which you could also write as 2 out of 125 or 1.6%. I'm not going to be too picky on how you choose to write your answer. There are 22 students in Mr. Jacobs' first hour Algebra 2 class. There are 19 juniors in the class. There are 7 females in the class. There are 6 female juniors in the class. If a student is selected at random for Mr. Jacobs' first hour, what is the probability that the student is either a female or a junior? So, female or junior, this is where we had that formula where the probability of A or B is when you add up A and B individually, and then you subtract the overlap, the and part of things. So we don't know this first part. That's what we're trying to figure out. Let's say A is junior. Let's say B is female. And then the and is going to be both, junior and a female. So we have 19 juniors plus 7 females minus the 6 female juniors. So 19 plus 7 minus 6, we should get 20. There are 22 students in the class, so 20 out of 22, or 10 out of 11, or 90.9%, however you want to write it. All right, next page. All right, the student senate in a different school consists of 5 juniors and 13 other students. 3 students will be selected at random for a committee. What is the probability no juniors will be selected? So the no juniors is the same as these 13 other students. So the different ways we could pick the 13 other students would be 13C3 over the ways we could pick any 3 students. So total, there are 18 students on the committee, the 5 juniors plus the 13 other students. So the bottom is going to be 18C3. So on top, we've got 13C3, which should be 286. The bottom, 18C3, 816. Divide those two numbers, and we get 35%. This one would not have a decimal because it would be or you could write 0.0. Excuse me. Question B. Using your answer from part A, find the probability that at least one junior is selected. So here, the reason they said, right, using your answer from part A is because at least one junior means one junior or 2 juniors or 3 juniors. So what we have up here is 0 juniors. So basically we want the complement of what we just found. So if there is 35% no juniors, then 100 minus 35 there is a 65% chance there is at least one junior. So this 65% covers when there is one junior and or 2 juniors or 3 juniors. All right. A bag has 3 red marbles, 5 yellow marbles, and 2 green marbles. Find the probability of drawing a red marble first and a green marble second if A, the marble is replaced, and B, it is not replaced. So the probability of finding a red marble is 3 out of 10 times the probability of drawing a green marble, which is 2 out of 10. So, and it's still out of 10 because we replaced that first marble, we put it back in. So we get 6 out of 100, which becomes 6%. Now for the second part, if we don't put that marble back in, it changes just a little bit. So the probability of getting a red marble is still 3 out of 10, but now we keep that red marble, so there are only 9 marbles in the bag. There are still 2 of them would be green, and so it's still 2 on top, but now we get 6 out of 90, which becomes 6.7%. So a little bit more. All right, last question here. A high school basketball team leads at halftime in 60% of the games in a season. The team wins 80% of the time when they lead at halftime, but only wins 10% of the time if they are trailing at halftime. What is the probability that a team wins a particular game during the season? So this one we are going to use a tree diagram. So we've kind of got it set up there. We just have to decide what goes where. So this first level, I would do leading or trailing at halftime. So here we could do leading at halftime and trailing at halftime. So leading and trailing. So it says that they are leading at halftime 60% of the time, which we need to convert to a decimal 0.60. So if they are leading 60% of the time, well then that means they are trailing 40% of the time. And then from there, the next level, I would do win or lose. So win, lose, win, lose. So when they are leading at halftime, they go on to win the game 80% of the time, which means they lose 20% of the time. When they are down at the halftime, they only win 10% of the time, which means that they lose 90% of the time. So then we want to know how many wins they're going to have per season. So we want to kind of get to our two W's here. So the first path we follow is just leading and then winning. The second path we can follow is trailing but then winning. So we multiply our way down those two paths. So 0.6 times 0.8, we get 48.48. And then 0.4 times 0.1, we get 0.04. So 48 plus 4, 0.04, we get 0.52. Yep. So, oh, sorry, I should not have put that percent there just yet. So 52% is the probability that they will win any one game. All right, that is our review. Let me know if you have any questions, and then when you are done with this, you can move on to homework or the Schoology quiz. Good luck!